Okay, so we've talked about classifying triangles and we've talked about angles in triangles. Now we're going to talk specifically about congruent triangles. These are triangles that have the same side lengths and the same angles. So congruent triangles. And we're going to draw a picture. So do your best to kind of make yours look as close to this as you can. We have one triangle here, and we're going to have another one that is similarly shaped, or actually the exact same shape, but it's going to turn in a different direction. And this will be A, B, C. This will be D, E, F. And I'm going to go ahead and go around and mark all the angles and all the sides congruent. So angle A is going to be congruent to angle D. Angle B is congruent to angle E. If you notice, my picture's not great. It doesn't look like they're exactly the same because we're freehand drawing these things. But the idea is that if they're marked, we don't have to worry about the picture being right. All that matters is, are they marked congruent or not? And we're also going to mark all the sides. So AB is going to be congruent to DE. BC is congruent to EF. And AC is congruent to the last side, which is DF. Okay, so notice the marks, where they're located, and what they mean. When we have a situation like this where all the angles and all the sides are the same, we can say that triangle ABC is congruent to triangle DEF. And this is a very important thing you're going to have to write over and over. This is called a congruence statement. So in your assignment and your work or on your test, don't be that kid that gets embarrassed and has to come up and ask me, Mr. Lewis, what is a congruent statement? It's this. This is a congruent statement. It's when you say two things are congruent and you list out all their little parts. So A, B, C, D, E, F. And if you'll notice, remember we said angle A was congruent to angle D, and here we have A and D. And then we said angle B was congruent to angle E. So we have B and E. And it works for the last one. Angle C is congruent to angle F. So we have C and F. The order of these letters matters. The order of these letters tells anybody looking at this which parts are the same, which parts are congruent, which parts are corresponding to each other. So if you were listing everything out, you would say that angle A is congruent to angle D, and this is what you'll do in some of your assignments. Angle B is congruent to angle E, and angle C is congruent to angle F, and AB is congruent to DE, BC is congruent to EF, and lastly AC is congruent to DF. So if you know the triangles are congruent, you know all of these things. All right, when we look at triangles like this and we see that all the parts are congruent, we might be doing something in a proof, and in our proof we might only need to say that angle A is congruent to angle E. And when we do that, because we already know the triangles are congruent, we know all the corresponding parts are congruent, there's a little saying that we use, and it's corresponding parts of congruent triangles are congruent. Okay, so just write it down. And this is what we write in our proofs for our reason. Like in our proof, if I wanted to say angle A is congruent to angle E, I would say My reason is corresponding parts of congruent triangles are congruent. But this comes up so much, this is such a commonly used reason in a proof, that it's universally known that we're going to abbreviate it this way. So when you go to college even, they're going to remember this. Your math professors are going to know this. Everybody that does math knows this. So we just say CPCTC, and that is what we write. That's what we write in our proofs. Okay, so we're going to do a quick example, one little proof. It's going to take us longer to draw the picture than it is to do the proof. So here is our little example proof. We're going to be given some info. We're going to be given that M is the midpoint of segment AD and segment BC. We're going to be given that segment AB is congruent to segment CD, and also that segment AB is parallel to segment CD. And we're going to be asked to prove that triangle ABM is congruent to triangle DCM. Now, that's interesting, but without a picture, it's absolutely pointless. So to draw a picture, this is going to be A, B. Now this is where you drawing the picture accurately is going to help you when you look back at your notes. So notice we're making kind of like a little hourglass thing, and it's just tilted a little bit, right? And the idea is that these triangles look congruent. Mine aren't great, but yours aren't going to be great either, so I'm not going to redraw it. Okay, we label it like this. We have this point here. This is M. So you would be given all of this information and this picture. And you're told that M is the midpoint of AD and BC. AB is congruent to CD. So AB is congruent to CD. And AB is parallel to CD. So this is what you're given. And we're going to prove that these two triangles are congruent. But to do that, we really need to prove all three sides are congruent and all three angles are congruent. So that's what we're trying to do. If we can prove all that, then we know the triangles are congruent. So we're going to start with reason 1, which is our given information. We'll start with M as the midpoint of AD and BC. And one habit that we're getting into, which is fine, but it's not really ideal, is that we write all the given information down the very first line. That's fine, but sometimes then you get confused about where stuff comes from later because you wrote it so long ago. So I'm just going to write down that part and work with that. So M is the midpoint of AD and BC. So what that should tell you is that AM is congruent to MD, right? So AM is congruent to MD. And also BM is congruent to MC. And the reason that's true, remember when we have a vocabulary word like this midpoint, the next thing usually is a result of that being a midpoint, so it's the definition of midpoint. Okay, then we'll move on to our next line. Remember, we're trying to say that all three sides are the same. So right here, when we said that AM is congruent to MD, right? Well, we've done one side of our triangle now. That was a side. And then we did BM, right? We did BM and we did MC. So that's another side. So we've done two of the sides, right? Just makes sense that let's go ahead and do the third side. So the third side is AB and CD. So we're going to say that AB is congruent to CD, And we don't have any special reason because that was given to us. So this is given. So that's an example how using your given later is just as good as using it all at once. So now we've said all three sides. Now we're going to want to say all three angles are the same. So the first thing we'll start with is right here. These two angles are the same, aren't they? So we can say that angle AMB is congruent to angle CMD. Or we could say DMC. It doesn't matter because we're talking about the angle in the middle. So why are those two angles congruent? That is the vertical angles theorem, right? It says that vertical angles are congruent. Now, the next one is a little bit tricky. So we want to somehow say that this angle A is congruent to this angle D. And how do I know that it's A and D and not A and C? Well, I look over at what I'm supposed to prove, and it says A and D go together. So I want to say that they're congruent, but I'm not quite sure how. But when I look at them, they kind of look like my picture of two parallel lines cut by a transversal, right? And that means they're alternate interior angles. And luckily up here it told me AB is parallel to CD. So I'm kind of good to go on this because I'm just going to say that, well, AB is parallel to CD. That's given. And because they're parallel, angle A is congruent to angle D, right? But go ahead and look back up there. This is also kind of like a transversal, right? Cutting through these two parallel lines. So that means this angle and this angle are congruent, and it's for the same reason. They're alternate interior angles. So my reason that angle A is congruent to angle D and angle B is congruent to angle C is the alternate interior angles theorem. And now if we look, I have said that one of the angles is congruent, and I've said that the other two angles are congruent. So I have all three sides and all three angles, so I'm ready to prove that they're congruent with my last line. Triangle ABM is congruent to triangle DCM, and the reason is that corresponding parts of congruent triangles are congruent. So CPCTC, I've proved all the corresponding parts are congruent, so therefore the triangles are congruent. So that's it, and that's one of the ways you can use CPCTC in a proof. Have a great day.